output001, it's the IP layer, that network protocol layer. And evolution of the IP layer has been painful over the years. So even going from IPv4 to IPv6 has been a 20-year process. And we'll talk about IPv6 a little later in the semester, but it's not a terribly ambitious protocol. It was not a huge change over IPv4. And even then, it's taken many, many decades to actually roll it out. Questions? Okay, so now, all we've done so far is decompose the problem. We haven't said exactly who's implementing what and how. Okay, so we're going to get to that next. And here the question is really distributing layers across the network. If all we were doing was taking those layers and running it in your laptop or somebody's server, that we wouldn't worry so much about exactly how we're assigning tasks or who's running what layer. The real challenge in the internet comes because we have to partition that functionality between the end hosts and the network. And that partitioning is really going to determine what the network implements, what is the job of the network. Okay? And so that's what we're going to do next. Let's first think about the end host. Okay? And I want you to tell me, what do you think, which layers get implemented at the end host? And now remember the layers, the two ends of it, you have the application, and then the very lowest layer is just the ability to put bits on a wire. So which of these functions do you think the end host has to implement? Yep. The application, for sure. What else? Does the end host have to be able to put bits on the wire? You're nodding your heads? Yes. Right? If I stick an Ethernet cable into my laptop, I expect my laptop to be able to actually send data over that Ethernet link, which means it must know how to put bits on the wire. And so bits arrive on the wire at your laptop or at your phone, which means you have to implement L1. And we also know we're running applications at the end host, so we know we're running L7. We have a strictly layered architecture. This means you have to implement all layers at the end host, all the way from picking bits up off the wire to handing it to an application. So all layers run at the end host. What about when we think about the network? Right? If I walk through that reasoning again, I would say, okay, bits come in on the wire, I have to implement L1. I have to be able to move packets from one switch to another across links, so I have to implement L2. And I have to do end-to-end delivery. That is exactly what the network's job was. So I have to do L3 as well. And we're going to talk about this at length, but the network does not implement layer 4 and layer 7. So it doesn't, crucially, no one expects the network to run applications. That was never really on the table. But the important thing here is that the network does not implement reliability or reliable data transport. And this is actually not what the first iteration of the internet did. So this was an important change when they changed from ARPANET, which was the government's first attempt, to what is today the internet. And so this gives us a very simple diagram that looks like this at the highest level, where the end host, you see all 5 layers, and a switch or router is implementing L1 to L3. Okay. I'm going to dig in on both the end host and the network view a little bit more closely now. Let's start with the end host. Right, so we said the end host, think of this as your laptop or server, implements all 5 layers. Right? What does that actually mean? Let's open up that end host. If you look inside your laptop or your machine, to first order, what you have is your network interface card. Right? This is where you go stick your cable in, or your wire in, or your radio lives. And then you have things that come in on that network interface card get handed to your operating system. And in particular, the networking stack within your operating system. What I mean by this are the portions of your operating system that handle processing traffic between applications and the network interface card. Okay? Because your operating system does a lot of things. So the networking stack is the relevant portion for us of the operating system. And then it also hands, hands packets up to the application. So we have these 3 major components within your end host. Should not be too surprising when you think of which layers get implemented where. We're going to put the application layers going to run at the applications, and the physical and data link layer are going to run on your network interface card. This is really the job of putting bits out onto the wire or packets out onto the wire. Where do you think your network and your transport layer should be implemented? It's pretty obvious. Yep. in the operating system. Any guesses on why? And we're now actually, I should say, in the realm of not you have to do it this way. We're more in the space of this is how common practice. Most systems you go look at, this is how they're built. Why would you put the network and transport port layer into the operating system?
You want the operating system to be able to think about making decisions in terms of like, should I send these packets or how do I structure what requests I'm sending out, and that's maybe a little bit more decision-making power than the mechanics we have.
That's reasonable. So you want to look, can I say you want to manage across applications. So you have all this traffic that different applications want to send out, and you want to be able to maybe do something intelligent with that, prioritizing one application over another, or making sure one application is not hogging all the traffic, or the bandwidth, sure. Anything else? Yep. Right. So that's the primary driver, which is this is a pretty general task. Imagine if every application you wrote, every time you had to write an application, you had to worry about how do I take this file or this key value store or this recording, and I have to chunk it up into packets. And then I have to worry about how to make sure that every packet gets delivered to the end host. I have to implement reliability. It would just be a lot of work for every application to redo it. You could, nothing stops you, but it's much more convenient to have that functionality in your operating system. To implement it once in a general fashion, and it's a general service that all applications can use. And in some sense, this is the role of the operating system, is to have services and abstractions that are useful for applications built on top of it. So that's why we have typically the network and the transport layer implemented in the OS. It's not the only way to do things. You can certainly find systems out there that either put this functionality at the application layer, or even increasingly these days, for example, in data centers that push that functionality down into your network interface card. And the reason they do that is simply to shrink the footprint, to not consume CPU resources on doing network and transport layer processing. Any questions on the end host? Right. There is another trick that you have to think about when you're looking at the end host. So let me ask you to think now about, that a packet is arriving at this end host. Okay. And we said the packet contains the destination address. This is the address, the unique address of this host on the internet. Okay. This is what allowed the packet to make its way across the internet and reach this end host. Now the packet arrives at the network interface card. Let's say the network interface card does something like it raises an interrupt. The operating system then sucks the packet up into the OS from the NIC. And now the packet is sitting at the operating system. When this packet arrives, how does the operating system know which application it should hand this packet to? Yeah? Right, exactly. So there should be some information in the header that allows the OS to know which application this packet has to go to. In everything we've talked about, so I haven't told you about this piece of information so far. Right? So you didn't actually have enough information to know how this packet makes it to the application. So now what we're going to do is introduce this concept of a port, that in the header there's going to be a port number that identifies which application you have to send, the OS has to send the packet to. In particular, that port identifies the attachment between an application and the operating system. So this can be pretty confusing, so let me clarify one thing. In networking, we have two different types of ports, and it doesn't help when students are trying to not be confused. So we have two different types of ports. One is physical ports. If I take a switch, or if you take your laptop, you have the physical port where you connect a link to that device. Okay? That's the ports I think many of us are familiar with. But there is also a logical port. The operating system supports this concept of a logical port that is very different, has nothing to do with the physical port on the switches. The analogy is that this is where the application connects to your operating system. And that's why we call it a port. But it's an entirely logical entity. Okay, so physical port, the thing on your device where you go plug in a cable. Logical port, where your application plugs in or connects to the operating system. And so in your next section, you're going to talk about something called sockets and how this relates to ports. Sockets is the operating system abstraction, or API, that allows an application to connect, or an application process to connect to the networking stack or your operating system. So you'll study this interface in depth, but the way this works is that when an application wants to connect or wants to access the network, it's going to open a socket. Okay? That's the abstraction the OS provides. The OS is going to associate that socket with a unique port number. Okay? Not the physical port number, this is the logical port number. And so now when port numbers get carried in packets, and so when a packet arrives at the OS, it says, this is the port number. It looks it up to see what socket is associated. It hands the packet to that socket, which is a way of handing it to the application. Okay? And you're going to see sockets in the interface, socket interface in much more detail. What I do want to focus on in this lecture, however, is the implications for the packet header. So far, we've said that a packet has to contain the destination address. Right? This is the information the network needed to get that packet to your end host. Now I'm telling you that packet should also contain a destination port. And this is used internally within your end system by the OS to know which application to hand the packet to. Any questions? Yeah?
When we're talking about applications, we're talking about one browser, not individual websites within that browser?
Right, it's a process. So from the point of view of the OS, it doesn't actually care what application is running in that process. It's a process. It just knows which process to hand it to.
Different websites have different ports?
Typically, if you had a different, you would be writing different server applications for different websites to serve different applications, and then they would bind to different ports. But you could also build it either way. So I think we went over this. When a packet arrives at the end host, it's delivered to the socket, which is a process associated with that packet's destination port. So really what we've created here is a role for the operating system where it acts as an intermediary between the applications and the network interface card. Okay? So the application has a very clear task. It thinks about data. It thinks about those key value stores, about files, about images. Right? That's what the application is concerned with. On the other hand, the network interface card, or the driver is the code that runs on or interacts with the network interface card hardware, has a very clear task. It has to think about packets and the link technology it's sending those packets over. The OS, or the network stack within the operating system, is what mediates between those two, what converts between those two. It takes that data and converts it into packets that the NIC can send out. That's the role of your OS and the network stack within your OS. It's a very important role. So I'm going to recap. At the end host, we have L7, typically part of your app, L3 and L4, typically part of the OS, and L1, L2, typically implemented in your network interface card. Any questions before I move on to the network? Yeah? Right. That's a great question, and I believe you covered that in section again. But typically, the way this will work is that the server side, remember, server listens for connections from clients. So a server will connect on a well-known port. Port 80 is probably the port you've heard about. A client can locally then pick any port it wants, connect to that well-known port, so that's how it knows which port to send a message to on the server. The server, when it receives the message from the client, knows what port it sent it on. So you just have to flip it around, and you know how to get back to your client. So moving on to the network side of things now. So again, recall we said we have this picture, all 5 layers at the end host, only layer 1 to layer 3 in the network. And we said layers on either side interact with the peers corresponding layer. They run the same protocol. We're going to dig down into that a little bit more now. Just to make this picture more useful and interesting, I'm going to add an additional router. So you can see that that interaction is not just between end hosts and routers, it's also between 2 routers. Okay. And I'm going to start looking at what protocols we are running at each of these layers now. Okay, so a very simple protocol diagram would say, these are examples, again, these are not the only protocols you could be running, these are very typical protocols that we run. So at the application layer, we could be exchanging HTTP messages. Okay. Again, I'm not telling you at this point how that message is actually flowing